Hello everyone, I am Miksha an MSc student at the Forensic Anthropology Research Center at the University of Pretoria in South Africa. Today I will be discussing my honors study, which was on a comparative analysis of dental measurements using different modalities, specifically caliper versus micro CT. Dentition. I know that this word does not usually ignite a room on fire or spark interest. But what if we go into new and innovative ways of handling and utilizing dentition in the field of forensic anthropology? Before we delve into the depths of this study, I would like to remind you what a tooth actually is. For this, we are going to quickly revisit dental anatomy. The tooth is made up of two components, the crown and the root, which is made up of four enamel tissues, the enamel, the dentine, the cementum, and pulp. So why are teeth so interesting for anthropologists? In forensic anthropology, for example, the main goal is to identify unknown remains by constructing a biological profile, and thus estimating sex, ancestry, and age of the individual. Multiple studies in South Africa focus on the cranium, pelvis, and postcrania in order to construct a biological profile. However, these bones are highly affected by the environment and hormones, subjected to postmortem damage, and not always recovered. Dentition, on the other hand, is minimally subjected to the above conditions, making teeth a highly reliable source. Furthermore, many studies have found that there are gender morphological dental differences noted for sex and ancestry, making dentition a useful element for the analysis of unknown remains and therefore the reconstruction of the biological profile. However, these dental studies are often characterized by small sample sizes or issues with their methodologies, particularly when using a caliper. Indeed, it was found that traditional caliper measurements on teeth are problematic and difficult to achieve, as the teeth need to be nearly perfect with little wear. The placement of the caliper also is often quite subjective, and finally, there is no real consensus on the definitions themselves of the measurements. The handling of some skeletal material can also be delicate and tricky or even destructive. Thus, other methodologies of measurement needed to be explored. An alternative methodology, virtual imaging. This method can prevent contamination and limits excessive destructive handling, preventing loss of essential evidence. Micro-CT, for instance, is considered as the gold standard of 3D imaging and is being used extensively due to its non-invasive, non-destructive nature and very high resolution, giving us access to very fine details. It allows for the virtual separation of different dental tissues and a 3D reconstruction of all the internal and external structures of the teeth with great accuracy and precision. Fields such as biological and forensic anthropology, dentistry, and archaeoanthropology have employed this method on teeth. Studies have already been done on comparing different scanning methods or comparing them to traditional caliper measurements for bone morphometrics. However, on teeth, we could only find 4 studies comparing virtual and caliper measurements. First, Kim et al. Did a study using only loose teeth extracted from patients, while Aubrey et al. Did caliper measurements on teeth in situ. They even found that the results could differ considerably due to the placement of the caliper. Then, Granhead et al. Took measurements on plaster models, almost the same with Casper et al. As they took measurements on the skull, plaster models, and CT. Finally, Baumgart et al. Looked at the comparison between CBCT and caliper. However, they were not measurements done on individual teeth, but arch measurements. In conclusion, there is really limited information on the procedure of taking dental measurements using a caliper that can be repeatable on virtual models for insert molars. Thus, The aim of this study was to compare dental measurements taken on in-situ teeth with two different modalities, traditional calipers and virtual models. For this aim to be achieved, we had several objectives. First, we wanted to establish a standard protocol for taking traditional measurements on 3D models. Then, assess the intra and inter-observer repeatability of measurements for each method. Finally, investigate the accuracy and reliability of both methods while comparing the measurements themselves obtained using the two modalities. The sample size of this study consisted of in-situ first and second molars from 60 mandibles from the Pretoria Bone Collection, hosted at the Department of Anatomy at the University of Pretoria, with the associated micro-CT scans. The inclusion criteria consisted of well-preserved in-situ teeth with limited wear and the absence of metal restorations which may cause artifacts in imaging acquisitions. Now that we collected all our teeth, what do? Caliper measurements were taken on first and second mandibular molars using a fine point digital caliper. Measurements were taken on the enamel surface at the cervico-enamel junction, the CEG, always from the buccal side of the mandible as recommended in many publications. Mesiodistal crown measurements were taken parallel to the occlusal surface, while buccolingual crown measurements were taken perpendicular to the mesiodistal diameter. Each molar was measured 3 times and the mean value obtained was used. Micro-CT scans of the mandibles were processed and analyzed using Aviso, an imaging software. The molars were then extracted from their data set, meaning that they were virtually extracted from the bone. Each molar was then segmented, which means that they were separated into their different components. Afterwards, the tooth was landmarked with B-splines around the CEG from buccal to distal, distal to lingual, and then lingual to mesial. We could then reorientate the image stack according to the cervical plane, our reference plane. Mesiodistal and buccolingual measurements were finally performed following Banazzi and colleagues' protocol. We wanted a virtual protocol as close as possible to what we do with calipers. 4 ortho slices were created and positioned on the mesial, distal, buccal, and lingual sides of the molar. We always checked that the slices were perpendicular to the cervical plane. The precise and final slice location was determined by the last voxel still visible at the CEG. The slice numbers were then used to calculate the mesiodistal and buccolingual max distance. For example, the mesiodistal distance was obtained by subtracting the distal slice number from the mesial slice number and multiplying that by the resolution of each scan. All statistical analysis was conducted in the R software. 10 molars were measured twice by the principal investigator and then by a second observer in order to assess the repeatability. The accuracy and comparability between the two modalities were also assessed. First, we checked the intra-observer repeatability. Both TEM and ICC showed very high repeatability and correlation for both mesiodistal and buccolingual micro-CT measurements, while caliper measurements showed high repeatability and correlation for mesiodistal measurements, but a moderate correlation for buccolingual measurements. Bald-Altman's plot showed in general high agreements with some measurement differences falling out of the upper and lower limits, but the differences were always less than 2 millimeters, which is acceptable in anthropological studies. It should be noted, though, that buccolingual measurements showed the greatest differences using a caliper. Then we assessed the inter-observer repeatability. Micro-CT measurements showed a very high repeatability, particularly for mesiodistal measurements, as well as high ICC correlations. Caliper measurements also showed a high repeatability for mesiodistal measurements, but with lower ICC correlations, and particularly low lower bounds of the confidence interval for buccolingual measurements. Bald-Altman's plot confirmed high agreements in general, with few differences always less than 2 mm, which is accepted. The biggest difference was noted for caliper buccolingual measurements with a wider spread of plots. Finally, we directly compared the modalities. Bald-Altman's plot showed a high agreement between micro-CT and caliper measurements for mesiodistal as well as buccolingual measurements. Some points were out of the interval limits but always less than 2 mm, which is accepted. We could notice something particular for buccolingual measurements on second molars, as the confidence interval had a shift with a mean lower than 0 and showed the greatest difference. Passing bubble-lock regressions showed a high correlation for mesiodistal measurements between the two modalities, with only a moderate correlation for buccolingual measurements. Finally, paired student t-tests found no statistical significant differences for mesiodistal measurements. However, buccolingual measurements were significantly different between the two modalities, specifically for second molars, and as observed on the box plot, always greater in caliper measurements than virtually. Three-dimensional imaging technologies, and more particularly micro-CT, are being used more frequently in the ever-modernizing world of forensic anthropology. This research project aimed to assess the accuracy and repeatability of micro-CT measurements compared to the traditional approach, using caliper measurements. The project also aimed to test and provide a concise and repeatable protocol in order to perform dental measurements on virtual models. Our results highlighted that intra and inter-observer repeatability showed strong correlations and high agreement in measuring mesiodistal and buccolingual distances using either caliper or micro-CT scans. However, both intra and inter-observer errors, micro-CT based measurements seem to achieve a higher degree of agreement compared to caliper measurements, confirming what we found in the literature. When considering the two specific types of measurements, no statistical differences between the modalities were found for mesiodistal measurements, either on first or second molars, but buccolingual measurements were more problematic. Indeed, while mesiodistal measurements were always found in high agreement between modalities, buccolingual measurements were closer to a moderate agreement, with average correlations and an overestimation of measurements by caliper compared to micro-CT, which was already found in multiple studies comparing caliper to other scanning modalities. These results are also consistent with issues encountered during data collection, and particularly when measuring buccolingual measurements using a caliper. The mandibular ramus and molar cusps impeded the correct positioning of the caliper, particularly for second molars. Similar issues were encountered by Aubrey et al. In 2014. Therefore, caution really needs to be employed for certain measurements, especially when different modalities are used in the same unique study without assessing their reliability first. Unfortunately, this is often the case, for instance, in paleoanthropological studies. For example, Keifu et al., or particularly Sloan et al., recently in 2017 used micro-CT dental measurements for certain groups of species, while they also used caliper measurements for some other species, and in the end made a comparison between all these species without even knowing if the differences noted were mostly due to the differences in modalities. In conclusion, as teeth are more resilient to post-mortem damage, to hormonal and environmental effects, and are thus often recovered in forensic cases or in archaeological contexts, teeth are always being researched to aid in sexual dimorphism and population variation. However, due to issues in methodology such as small sample sizes, a shift towards virtual modalities was noticed and may be needed to help improve data collection and to have access to large and more representative worldwide samples, which is great. As this study found that not only are micro-CT and caliper measurements repeatable, but also that the standardization of measurements is simplified when using micro-CT scans, resulting in high measurement repeatability. However, even if Mesiodistal micro-CT measurements were found reliable and repeatable and thus may be utilized in forensic anthropology or dentistry, further research is still needed, especially for buccolingual measurements, in order to develop and provide an even more accurate procedure. I would like to acknowledge the following people for their support and resources during this study. Thank you all for watching. Should you have any questions, please feel free to email me. The micro-CT scans used in this study will be available soon on the Bakengsa Africa Digital Skeletal Repository. Should you wish to have more information on this project, please use the QR code to access our blog and our social media. Thank you.